Probability is the likelihood of an event to happen or not. How likely it is that a proposition is true or not. Proposition means if some statement what you are telling, say it will rain or not, or you will pass or fail, or you will get a job or not. The likelihood. Probability means the chance of occurring something, that is probability. Then the most important property of probability is that it is a value, or when you find the probability of any event, probability of that event always lies between 0 or 1. Okay, it lies between either 0 or 1. Okay, then where if you say probability is 0, it means that it is an impossible event. Say for example, I am telling you 8th day of a week. 8th day of a week. Does it happen 8th day of a week? We know there are only 7 days in a week, Sunday to Monday. Okay, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, that much only. Okay, so probability is say P of any event day is equal to say 0.95. Then it means that it is very likely to happen. Similarly, if P of A equal to say 0.01 means the probability of happening of that event is very minute, very negligible chance of happening that one. So always remember that the probability of any event lies between 0 and 1. Okay, trial. Trial, or we say experiment. Okay, now for example, if I am throwing a coin, all of you know a coin has two sides, head and tail. If I am throwing a coin or tossing a coin, that tossing of a coin is an experiment. Okay, tossing a coin, that is an experiment, or that's a trial. Now when you toss a coin, you know there are two possible outcomes, two possible results. When you toss a coin, either you will get a head or you will get a tail. Okay, so these are the possible outcomes, means when you toss a coin you will get either a head or a tail. Then this process of tossing, or that process is called as an experiment or a trial. Okay, so that any event, any activity which you repeat and you are sure that you will get an answer there, that is a experiment repeated under same conditions and it will result in possible outcomes, then that experiment we call as a trial and the possible outcome we call as the event. Conclusive event means when one event is happening. Say for example, when you toss a coin, you know either you will get a head or tail. It is very much sure that if the coin is a fair coin, then it is very much sure that if you are getting a head, there is no chance of getting a tail. Okay, that tail you will not get. Then such events are called as mutually exclusive. Mutually exclusive means they are independent of each other. Mutually exclusive. H is if you are getting a head, then you will not get a tail. Similarly, when you throw a die, if you are getting the number 1, there is no chance of getting any other digits. If you are getting number 6, there is no chance of getting any other 1, 2, 3, 4, 5. Okay, so such events are called as mutually exclusive events. That is, events in which happening of any one of them rules out the happening of all others. That means no two or more than two events can happen simultaneously. Okay, so equally likely events. Example, when a card is drawn from a well shuffled pack, any card may appear in the draw so that the 52 cases are equally likely. Throwing a die, that is the event. Throwing a die, that is the experiment, trial we are doing. Then sample space. Sample space means the result. The outcomes can be 1, 2, 3, 4, 5, 6. These are the possible outcomes. Okay, so these possible outcomes, set of all possible outcomes we call as sample space. So sample space means set of all possible outcomes while performing a trial or while performing an experiment. That is the sample space. So each one is an outcome here. 1, 2, 3, 4, 5, 6. Each one is an outcome. Now in this one I am going to define an event. So an event is always a subset of a sample space. From the sample space we are going to define an event. An event I am defining as getting an even number. Getting an even number while a die is thrown. This is the event I defined. Okay, while a die is thrown, getting an even number. That is my event. Okay, now out of this one. So out of this one. So that event, suppose I am defining this event as A. A is the event of getting an even number while a die is thrown. So this A will have, what all things will be there in A? N of S, number of elements in S is 6 and number of elements in A is 1, 2, 3. Number of elements in A is 3. Okay. Then by definition of probability of A is number of elements of A divided by number of elements of S. Okay. Number of elements of A means event, that is in the event how many elements are there, in event A how many elements are there, and number of elements in S means the total sample space of elements in number of elements in the sample space. So number of elements in A is 3 and number of elements in S is 6. So it is 3 by 6 means 1 by 2. That means the probability of getting an even number while throwing a die is 50%. 1 by 2 means 50-50, because we know it's very clear from this sample space also. 1, 2, 3, 4, 5, 6. So getting 2, 4, 6 is exactly half of this total. Okay, so probability of getting an even number is 1 by 2. Now if I ask you, suppose I define B is equal to, B is an event, define B is an event in which a phase with prime number. So B you will have 2, 3, 5, and 2 is the only even prime number which is the smallest one. Okay, so here if I ask you P of B will be N of B divided by N of S. So that also will be, you will have 3 by 6, that means 1 by 2. So that is the definition of conditional probability. Is the probability of an event occurring given that another event has already occurred. Already some event has occurred, and depending on that one you are defining the probability of an event. Okay, so that is conditional probability.